So the kind of mathy way of doing this, identifying these graphs, would be to plot some points. You know, if we think about an R and plug that in to find out what theta is, that can give us some points in polar coordinates where we know our graph exists, where points of our graph exist. So if we plug in, let's say we plug in 1 in for R, then we have this equation: 1 equals 4 cosine 2 theta. This one's going to come out kind of yucky because if we divide 4 from both sides, this isn't like a standard trig value, 1/4, right? So let's do this one. Then we'll try plugging in 2 next for R, because 2 divided by 1/4, that makes 1/2. And then we know what cosine of an angle could be to make a 1/2 ratio, because that's one of the special triangles we've studied. But for this one, we're going to use a calculator. So let's keep things in radians. And I'm going to put 1/4. I'm going to use second cosine, because I'm using inverse cosine of both sides of this equation. So the left side, when I use inverse cosine, is 1.318. That equals 2 theta. And so to finish getting theta by itself, I just need to divide by 2. That's 0.659. And we could also sit there and think about the fact that this is a positive value for cosine. Cosine is positive in the first quadrant and down here as well. Okay? So if this angle is 0.659, then negative 0.659 should also be an angle on our graph, because this would be the same theta down here, just negative, going in the opposite direction. Maybe that can help us rule something out. That means we have a point that's one circle away, because it's 1 in unit distance away from the origin, and then an angle of 0.659. Oh, they have everything in degrees actually. So let me go back. 1/4. I'm going to switch to degrees, and then second cosine 75. Then we got to divide that by 2. So I've got a 37.76. So actually use degrees. I didn't see that they were using degrees in this problem. So negative 37.76. So what we should be doing is looking at around 37.6 degrees. And 1 in 1 for R. It should be 1 unit away. There should be a dot somewhere right around here. This graph doesn't have it, so we can eliminate that one. So here's 37, roughly 37 degrees, somewhere between 30 and 60 degrees. And here is 1 distance away. There's 1 for R, because that's 1 circle away. This one is possible. Okay. Let's check this one. 37 degrees. 1. This one's possible, because that has our dot that we said it's supposed to have. 37 is roughly around here, and 1. This one's missing it. This one I think we can safely rule out, because 37 degrees is definitely way closer to 30 degrees than 60 degrees, and there should be a 1 on the first circle. So that doesn't happen. 37 and 1, this one's ruled out as well. So by plotting in one value for R, we were able to eliminate 3 graphs. We're down to just 2. And then we're also supposed to have at negative 37.76 degrees, so which means we're going in the opposite direction. So this would be negative 30. So negative 37.7 and 1 for R would be right here. That one is possible. Negative 30.7 and 1 for R. This one is also possible. Okay, so that didn't help us eliminate any of them. These last 2 are still in the running. So let's try plugging in 2 in for R. Oh, actually, that's not going to work, because 2... yeah, that'll be fine. Plug in 2 in for R. So 2 squared equals 4 cosine 2 theta. So that's 4 equals... I thought it was going to be 1/2 because I forgot about the squaring. But plugging in the 2, divide 4 from both sides. And so now, if you were to use inverse cosine with the calculator, or you could think about it like this, like what values for cosine does the ratio equal 1? Cosine is the x-coordinates in the unit circle, and it's 1 in only one place when this equals 0. Okay, so the angle should equal 0, or in other words, you could use your calculator here. Use inverse cosine just like we did before. trig inverse cosine gives us 0. In other words, theta should equal 0. So we should have a dot 2 circles away when we're at 0 degrees. So that rules this one out. That's where the dot should happen. 0 degrees, 2 circles away because it's 2 in distance away from the origin. 2 in distance, this one is our winner. So by plugging in 2 points, we are able to figure it out. I know there's a lot of online tools out there to help you with this problem. I guess there's no way of me stopping you from using them, but you know, the only way we're going to get really good with polar coordinates and perhaps use them in our future math classes is if we practice plugging in the points and getting used to what happens with them. So I definitely suggest this approach. I guess